Hey guys, Mr. B here. Welcome to part 2 of the 3.1 notes on scientific measurement. In this part, we're primarily going to be going over significant figures and what those are and how they work in measurements. So let's get started. What are significant figures? All right, so suppose that you're going to estimate a weight, and let's say that you know that the weight is somewhere between 2.4 and 2.5 pounds. So you estimate it to be 2.46, okay? Now, the first two digits, the 2 and the 4, you know for sure, for certain, it's 2.4 something. The last digit, however, the 6, you had to do a little bit of estimating, okay? So there's some uncertainty there because you don't necessarily know it's 2.46. It could be 2.47, could be 2.45. You just know it's going to be 2.4 something because it's in between the two, it's in between 2.4 and 2.45 pounds, okay? So all three digits that you have written down here for your measurement contain very important information, and these are what we call your significant figures. So significant figures in a measurement are all the digits that you know plus one last digit that is usually always estimated, okay? Now measurements always have to be reported to the correct number of significant figures because the answers that we get with our calculations are oftentimes very dependent on the number of significant figures in the measurements that we use to get those calculations. So we'll take a look at how do we measure things using proper Sig Figs as well as the math when we have to use that too. So there's three rules when it comes to significant figures, okay? The first two rules here are for whole numbers only. Okay, so there's three rules, but the first two really apply to whole numbers, and the last one applies to numbers with decimals. So rule number one, all non-zero numbers are significant, and zeros are not significant, which means that any number that is between 1 and 9 automatically counts as a significant figure, and if there's a 0, it does not count. Okay, so for example, the number 100 has one sig fig, and that is just the 1. The zeros don't count. For rule 2, zeros can be significant if they're sandwiched between non-zero numbers. So for example, the number 101, this would have three significant figures. The two ones automatically count based on rule number 1, and the 0 counts in this case because it's sandwiched between two ones, which are not zeros. Okay? So counting significant figures in numbers that are whole numbers is pretty easy. You look at the numbers that are not zeros, those count, and you count zeros that are sandwiched between things, ones that are not, don't count, okay? And it doesn't matter how many zeros are in between, all of them will count. So for example, you could have the number 1,000,001, and all of those zeros that are sandwiched between the two ones count, okay? You can put as many zeros as you want in between non-zero numbers. Those zeros all count. Okay. As for the third rule, this one is with decimals. So this rule that we're about to talk about here does not apply to numbers that are whole numbers. Okay, it only applies to numbers with decimals, and these first two rules with whole numbers do not apply to numbers that have decimals in them. So if there is a decimal point present in your number, the easiest way to do it is you're going to read your number starting from the left. Okay, so you're kind of like working your way in. And the first number that you hit that is not a 0, that is your first sig fig. Okay? All other numbers that come after that automatically count as being significant. So for example, the number 0.00156. If we work our way into this number from the left, the first digit that we hit that's not a 0 is the 1. That's our first sig fig. And then everything after that automatically counts. So the 5 counts, the 6 counts, which means this number has 3 sig figs, okay? Second example, 0.001089. Again, if we work our way in from the left, the first number that we hit that's not a 0 is the 1. And so that's our first sig fig, and then everything after that automatically counts. So this would have a total of 4 significant figures. Our last number, 293.0800. The first number we hit that is not a 0 is right away at the beginning, and that's the 2. So that's our first significant figure right at the beginning, and then everything after that automatically counts, which means all of the digits in this number are significant. So this would have a total of 7 significant figures, okay? Now you'll notice that there are zeros here that are at the end that aren't sandwiched. Doesn't matter. Remember that the sandwich rule from this previous slide only works when you're dealing with whole numbers. This is not a whole number. There's a decimal there. Therefore, the sandwich rule doesn't apply here, okay? Same thing with the other rule. Anything that's not, any number that's not a zero, that part again doesn't matter either because that only works with whole numbers. These are not whole numbers. So it's really like two rules, right? You got rules for whole numbers. You got rules for numbers with decimals. As long as you don't confuse them, it's pretty simple. Okay, so this just shows you an example of how significant figures really come in play. In this first estimate here, we're using a piece of metal to measure the length of a piece of wood. The piece of metal is 1 meter long. Using this piece of metal with no other markings on it, we could maybe estimate this piece of wood to be 0.6 meters. We'd have one significant figure. Now, if we got a piece of metal that has markings on it every 10 centimeters, now we can have more significant figures in our measurement because we can now see that this is at least 60 centimeters plus a little bit more. So maybe now we can estimate it as 0.61 meters. Now our measurement has two significant figures. It's more precise. Or we could have a piece of metal that has markings every 10 centimeters and every 1 centimeter. So now we can be even more precise, and now we can make a measurement that's like 0.607 meters. So now this has three significant figures, and it has an even higher level of precision, okay? So the significant figures really tell you how precise your measurements are, and it's important to make sure you use the right number of sig figs when making measurements. All right, so here's just some quick practice, just counting number of significant figures in a measurement. We're going to go through 3 of these. So first one I'll do is letter A, and that is how many significant figures are in 123 meters. All right, well, this is a whole number, which means that the first 2 rules we're going to use. So anything that's not a 0 automatically counts. So the 1, the 2, and the 3. And since that's all there is in this number, that would mean that this has 3 sig figs. Okay, sig figs we just abbreviate as significant figures. So 3 significant figures, pretty easy. All right, let's take a look at letter C. 9.8000 times 10 to the 4th meters. All right, now this one's a little bit trickier because we have something in scientific notation. Don't freak out. Okay, the scientific notation part, this times 10 to the 4th, we ignore that. The only part we're looking at is this first part, 9.8000. That's all we're counting when it comes to sig figs. So this number is not a whole number. It has a decimal in it, which means that if we work our way into this number starting from the left, the first digit we hit right away that's not a 0 is the 9. There's our first sig fig, and everything after that automatically counts, which means every single digit in this number is a significant figure. So this would have a total of 5 sig figs. Okay? All right. Last one we'll take a look at is letter F. So this is 98,000 meters. All right. Now this one, oh, my bad. This one is a whole number. So we're going to use the first 2 rules, which is any digit that is not a 0 automatically counts as significant. And zeros only count if they're sandwiched. So in this case, the 9 and the 8 are significant figures, but the zeros are not because they're not sandwiched between non-zero digits. Therefore, this would only have 2 sig figs, okay? All right, so if you'd like, you could pause the video and try doing letters B, D, and E. Otherwise, we are going to do some more practice as we go forward, so up to you. Anyway, let's keep on moving. Okay. So when it comes to sig figs, 1, being able to count them in a number is important, but 2, the real main part where they come in handy is when we have to do math with them. How do we do calculations with sig figs? So the main thing we need to understand is that our answer that we get cannot be more precise than the least precise measurement from which it came from. So what the heck does that mean? Basically means is, if I'm going to use that piece of metal, as was shown in this previous picture here, okay? If I'm going to use this piece of metal to measure this piece of wood, I cannot give an answer like this one here in the third diagram, okay? If I was measuring this piece of wood using this piece of metal that's only 1 meter long and there's no markings on it, I couldn't give an answer of 0.607. And I can't do that because this answer down here in this third diagram has decimals to the thousandth of a meter, right? We have 0.607. That's a thousandth of a meter. And this piece of metal up here in the very top doesn't have markings to the thousandth of a meter or hundredth of a meter or a tenth of a meter. It only has just a full meter long. So the best I can do is estimate it to a tenth of a meter, and that's it. I can't go any further, okay? I can't give a super precise answer like part C here because the tool I'm using doesn't have markings that measure that small. Okay, that's what that's saying. So when we do calculations, we need to be aware of the numbers we're using to get our answers and make sure our answer reflects the numbers we use to get it. So a lot of times we have to do rounding. Okay, we're going to have to round our answers to the proper number of significant figures based on the measurements that we started with. So to round our number, we first need to figure out how many sig figs our answer should have. And then that is going to be dependent on the measurements that we use to get it. So we'll take a look at the measurements that we use to get it, then we'll round our answer to the right number of sig figs. So real quick, just to take a look at an example of just doing some rounding. These problems here are three numbers, and they just want us to round our numbers to the right number of sig figs. So looking at letter A, we have 314.721 meters, and they want us to round this to 4 sig figs. Now currently, this number has 6 significant figures, okay? To round it to 4, that means that we're gonna keep the first 4, which is 314.7, and then we are going to determine whether or not the 7 is gonna round up to an 8 or stay as a 7. And to do that, we're gonna look at the number next to it, which is a 2. Okay, now rounding rules, if it's a 5 or higher, it rounds up. So the 2 is going to keep that 7 as a 7, which means 314.721 meters rounded to 4 significant figures would be 314.7. Okay, so that's how we do our rounding. We'll do these next ones also just to get some more practice. So 0.001775 meters rounded to 2 significant figures. Now currently this number has 4 sig figs, okay? 1775. Those are 4 significant figures. And we want it says here to round it to 2. So the first 2 would be the 1 and the 7. Okay, those would be our first 2 sig figs. So 0.0017. And then after the first 7, there's another 7, which would round that 7 up to an 8. So this, instead of 0.0017, would be 00.18 meters. And that would now be rounded to 2 sig figs. Okay, and the 2 sig figs are the 1 and the 8. All right, as for the third one, 8,792 meters. This one needs to be rounded to 2 sig figs. Now this one is a little bit tricky, but we're gonna try to do it, make sure we understand. So we need to round this to 2 sig figs, which means the 8 and the 7 are our first 2 significant figures, okay? 8 and the 7. And then the 9 is going to round the 7 up to an 8 because, of course, 9 is higher than 5. So the 7 now is going to become an 8. Now here's the part where it's tricky. We would go, okay, we keep this 8, we keep the 7. The 7 here gets rounded up to an 8 because of the 9, so we get 88, bam, 88 meters. 2 sig figs, right? Wrong. And the reason now is we've lost the value of our number. Our number was 8,792 meters, and we just rounded it to 88 meters. 88 meters is nowhere even close to 8,792 meters, right? The proper way to round this is you round the 7 up to an 8, but then you got to add 2 zeros onto the end. So now we have 8,800 meters, which is basically 8,792. We just rounded it up. And we still have 2 sig figs because the 2 8s are significant, but the zeros are not because they're not sandwiched. Okay? So make sure when you do your rounding that you don't round the number to the point where you lose the value of the number because you're so just stuck on getting the right number of sig figs. Okay, so other than learning how to round, what do we do with our calculations? Well, it depends on what mathematical process we're doing. If we're doing addition and subtraction, what we're going to do is we're going to round our answer to the same number of decimal places as the measurement that had the least number of decimal places. What the heck does that mean? Let's take a look at an example. Okay, so in this problem, we have 12.52 meters. we have 12.52 meters plus 349.0 meters plus 8.24 meters equals. Now, if I add all these together on my calculator, okay, so if I add all these together real quick on my calculator, we get 369.76 meters. Now, you might go, okay, no problem, right? Simple addition. We need to round this. Now, if we look at the measurements we used to get this, the first measurement had 2 numbers after the decimal. The second measurement only had 1 number after the decimal, and the third measurement had also 2 places after the decimal. So this number here in the middle had only 1 number after the decimal, which means our answer can only also have 1 number after the decimal. Now our answer currently has 2 numbers after the decimal. So what we're going to do is we're going to round the 7. We're going to keep all of this, 369.7. And the 7 here is going to round up to an 8 because of the 6. So our proper and final answer should be 369.8 meters using proper significant figure rounding rules. Okay, that's what we're talking about here. So our answer needs to be rounded to the same number of decimal places as the measurement with the least number of decimal places. In this case, the least number of decimal places in our measurements was 1 place after the decimal. Therefore, our answer needs to be rounded to 1 place after the decimal. Okay. When it comes to multiplication and division, that's the other mathematical process we can do. For this one, it's a little bit different. So in this case, we're going to round our answer to the same number of significant figures as the measurement with the least number of sig figs. So now what we're going to do is we're actually going to count how many significant figures are there in the measurements that we're using in our calculation, and our answer needs to be rounded to the same number of sig figs. In this case, we don't care how many places after the decimal there are. Okay, we're not looking at the decimal point. We're not looking at how many places after the decimal our numbers have. That's when we're adding and subtracting. This case, we're actually going to count number of sig figs. So let's take a look at some examples. Okay, letter A. We have 7.55. Oh, it's not underlined. This 7.55 meters times 0.34 meters. Now, this first number here, 7.55 meters, that has, we'll do this in black so it stands out more. This has 3 sig figs. Okay, we'll go SF, 3 sig figs. 0.34 meters, that has 2 sig figs. So our final answer, based on our measurements here, since this one has the least number of significant figures, our answer needs to be rounded to 2 sig figs. So if I do this again on a calculator, 7.55 times 0.34, my calculator tells me 2.567, and technically this would be squared meters. Okay, meters times meters is squared meters. But this is what my calculator tells me. I cannot keep it this way though. I need to round this answer to 2 significant figures. So the first 2 sig figs are the 2 and the 5. Oh, I did not mean to do that. Hold on a second. Let's undo that. Undo, undo. Equals, there we go. So 2.5, those are first 2 sig figs. And then this 6 is going to round the 5 up to a 6. So our proper answer, rounded correctly, would be 2.6 squared meters. Okay, that is our answer, 2.6 squared meters. All right, let's take a look at letter B. So we have 2.10 meters times 0.70 meters. This one is basically just like letter A, where we have our first measurement with 3 sig figs and our second measurement with 2 sig figs. So again, if we do this on a calculator, 2.10 times 0.70, I get 1.47, and again, it would be squared meters. But I need to round this to 2 sig figs, so I'm going to keep the 1 and the 4, and the 7 will round the 4 up to a 5. So my final answer here, rounded properly, would be 1.5 squared meters. Okay? All right. Last one, letter C. We have 2.4526 meters divided by 8.4 meters. Okay, now this is division, but it still is the same exact thing as we did in the other one. So let's count the number of sig figs in our first number. In this case, we have 5 significant figures. And in our second number, we have 2 sig figs. So again, if I do this on a calculator, oh, gosh darn it. Didn't mean to do that. Stop. Go back. There we go. Okay, if I do this on a calculator, so 2.4526 divided by 8.4 equals, I get a really long number, 0.29197619. Okay? All right. Well, I can't keep all of these numbers or all these digits. I need to round this to 2 significant figures. So the first 2 sig figs are the 2 and the 9. Okay? Those are my first 2 sig figs. So I'm going to keep those. So it's going to be equal to 0.29. And then the 1, which comes after the 9, would keep the 9 a 9. So my final answer here is going to be 0.29. Okay, 2 sig figs. Also, there'll be no unit on this one because we have a number in meters. Oh, I'm sorry, this did not have meters, so there should be a unit. This should just be meters, 0.29 meters. Disregard what I was about to say. So anyway, there we go. Okay, that's how we round. Hopefully that makes sense. But anyway, I believe that is it for this section of notes in this video. So hopefully that helps explain a bit more, but there's a video of me going over the practice problems as well as there's other practice also for you. So if you have any questions, though, as always, feel free to email me. You can talk to me in class in person, or you can reach out and we can do Google Meet. But again, as always, make sure that you get the help that you need. All right, guys, I'm Mr. B, and that's it for this section. I'll see you in the next one. Bye.